Okay, everything's nice and straight in here.
Okay, can you pull the door open a little more?
Right? Yeah.
Okay.
Did you get the mate down?
I'm going to pull it now. Houston, the Mesa came down. All right.
Houston, roger, we copy and we're standing by for your TEV.
Houston, this is Neil, radio check.
Neil, this is Houston, loud and clear. Break, break. Buzz, this is Houston, radio check and verify TV circuit breaker in.
Roger, TV circuit breakers in. And base 5 clear.
Roger. And we're getting a picture on the TV.
TV. Okay. You got a good picture, huh?
There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail.
Okay, would you verify the position, the opening I ought to have on the camera?
Stand by. Okay, Neil, we can see you coming down the ladder now.
Neil, we can see you coming. Okay, I just checked getting back up to that first step. That isn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera.
Okay.
I'm at the foot of the ladder. The LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind. As the surface is fine and powdery, I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. I only go in a small fraction of an inch, maybe an eighth of an inch, but I can see the footprints of my boots and the treads in the fine sandy particles.
Neil, this is Houston. We're copying.
There seems to be no difficulty in moving around as we suspected. It's even perhaps easier than the simulations of 16G that we performed in various simulations on the ground. Absolutely no trouble to walk around. Okay, the descent engine did not leave a crater of any size. It has about 1 foot clearance on the ground. We're essentially on a very level place here. I can see some evidence of rays emanating from the descent engine, but very insignificant amount. Okay, Buzz, we ready to bring down the camera?
I'm all ready. I think it's 2 miles squared away in good shape.
Okay.
Okay, you'll have to pay out all the LEC, Ned. Looks like it's coming out nice and evenly.
Okay, it's quite dark here in the shadow and a little hard for me to see that I have good footing. I'll work my way over into the sunlight here without looking directly into the sun.
Okay, it's taut now.
Unofficial time on the first step, 109.2420.
Okay, I think you're pulling the wrong one.
I'm ready to pull it down now. There was still a little bit left in the...
Okay, don't hold it quite so tight.
Okay?
Okay.
Looking up at the LEM, I'm standing directly in the shadow now, looking up at Buzz in the windows. And I can see everything quite clearly. The light is sufficiently bright, backlighted into the front of the LEM, that everything is very clearly visible.
Okay, I'm going to be changing the
Okay.
Surgeon says that
Camera installed on the RCU bracket.
surgeon says the crew is doing well. Data is good, crew is doing well.
And I'm still in the LEC on the secondary stud. I'll step out and take some of my first pictures here.
Roger, Neil, we're reading you loud and clear. Let's see, getting some pictures and the contingency sample.
Thirty-five and a half minutes of PLSS time expended now.
Neil, this is Houston. Did you copy about the contingency sample? Over.
All right, you're going to get to that just as soon as I finish these picture series.
Okay, gonna get the contingency sample there, Neil?
All right.
Okay, that's good. Okay, the contingency sample is down and it's up sample. Like it's a little difficult to dig through the initial crust.
Very interesting. It's a very soft surface, but here and there where I plug with the contingency sample collector, I run into very hard surface, but it appears to be very cohesive material of the same sort. I'll try to get a rock in here. Just a couple.
Oh, that looks beautiful from here, Neil.
It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Be advised that a lot of the rock samples out here, the hard rock samples, have what appear to be vesicles in the surface. Also, I'm looking at one now that appears to have some sort of phenocryst.
Houston, roger out.
Okay, the handle is off the it pushes in about 6
push it in farther, but it's hard for me to bend down farther than that.
Didn't know you could throw so
You
far.
can really throw things a long way up here. My pocket open, Buzz?
Yes, it is. It's not up against your suit, though. Hit it back once more. More toward the inside. Okay, that's good.
That in the pocket?
Yeah, push down. Got it? Now, it's not all the way in. Push it. There you go.
Engine's example is in the pocket. My oxygen is 81%. I have no flags, and I'm in minimum flow.
This is Houston, Roger Neil.
Okay, I got the camera going at 1 frame a second.
Okay?
And I've got 80%, no flags. Good.
Are you getting a TV picture now, Houston?
Neil, yes, we are getting a TV picture. Neil, this is Houston. We're getting a picture. You're not in at the present time. We can see the bag on the LEC being moved by Buzz, though. Here you come into our field of view.
Oh, Buzz, let me move that over the edge for you.
Okay, ready for me to come out?
Yeah, just stand by a second. I'll move this over the handrail. Okay?
All right, that's got it. Are you ready?
All set. Okay, you saw what difficulties I was having. I'll try to watch your bliss from underneath here.
All right, the backup camera is position.
Okay, your bliss looks like it's clear and okay. Your toes are about to come over the sill. Okay, now drop your bliss down. There you go, you're clear. And laterally you're good. Got an inch clearance on top of your bliss.
Okay, you need a little bit of arching of the back to come down. How far are my feet from the
Okay, you're right at the edge of the porch.
Okay. Back in from... Small little foot movement. Porch. Arching of the back. Moment comes up and clears the bulkhead without any trouble at all.
Looks good.
45 minutes PLSS time expended.
Neil, this is Houston. Based on your camera transfer with the LEC, do you foresee any difficulties in SRC transfer over?
Difficulties in SR. Negative.
That's the sample return containers, the rock boxes that Capcom...
No, I want to back up and partially close the hatch. Making sure not to lock it on my way out.
Particularly good thought.
That's our home for the next couple hours. We want to take good care of it. Okay, I'm on the top step and I can look down over the RCU and landing gear pad. That's a very simple matter to hop down from one step to the next.
Yes, I found it to be very comfortable, and walking is also very comfortable. You've got 3 more steps and then a long one.
Okay, I'm going to leave that 1 foot up there and both hands down about the 4th rung up.
There you go.
Okay, now I think I'll do the same.
A little more. About another inch. There, you got it?
That's a good step.
Yep. About a 3-footer.
Beautiful view.
Isn't that something? Magnificent sight out here.
Magnificent desolation.
Both PLSS is nominal on consumables.
Looks like the secondary strut. Have little thermal effects on it right here, Neil.
Yeah, I noticed that. Seems to be the worst, although similar effects are on all around.
Very, very fine powder, isn't it?
Isn't it fine?
Right in this area, I don't think there's much of any, but fine powder. Some clouds together, and it's hard to tell whether it's a clod or a rock.
Notice how you can pick it out.
Yeah, and it bounces and then reaching down, fairly easy. Got my suit 30 at this stage. The mass of the backpack does have some effect in inertia. There's a slight tendency I can see now to backwards due to the soft, very soft texture.
Oh, you're standing on a rock, big rock there now.
patcher didn't.
No, it didn't.
Absolute no crater there at all from the engine.
No.
I wonder if that right under the engine is where probe might hit. I'd like that.
Yeah, I think that's a good representation of our sideward velocity of touchdown. That folded the probe.
I'll see that probe over on the minus Y strut. Broken off and bent back up.
That did, didn't it? The other two both bent over.
Can't say too much for the visibility right here without the visor up. Pretty dark. It looks like there's a surface of a flat rounded rock. And incidentally, these rocks, very powdery surface.
Say again, please, Buzz. You're cutting out.
And here's some...
I say that the rocks are rather slippery.
Roger.
Very powdery surface. When it's on there, fill up all the very little fine porises. They'll tend to slide over it rather easily.
Neil Armstrong getting ready to move the TV camera now out to its panorama position.
Traction seems quite good. Particular area. Start to lose my balance in one direction, and recovery is quite natural and very easy. And moving arms around, Jack doesn't off the surface. Not quite that light-footed.
And I have the insulation off the Mesa now. The Mesa seems to be in good shape.
You have to be careful that you're leaning in the direction you want to go, otherwise you slightly inebriate. In other words, you have to cross your foot over to stay underneath where your center of mass is. Hey Neil, didn't I say we might see some purple rocks?
Find a purple rock?
Yep. Very small, sparkly fragments are rock. They're reflecting sun in places. That would make a first guess at some sort of biotite. We'll leave that to the further analysis. But soil compacts underneath. Completely no. You don't sink down more than a quarter of an inch.
Biotite is a brown mica substance.
Okay, Houston, I'm going to change lenses on you.
Roger, Neil.
Life support consumables still looking good.
Okay, Houston, tell me, get a new picture.
Neil, this is Houston. That's affirmative. We're getting a new picture. You can tell it's a longer focal length lens. And for your information, all LEM systems are go. Over.
For your information, all LEM. I appreciate that. Thank you. Is now unveiling the plaque that is.
Roger, we got you bore-sighted, but back to one side.
Bore-sighted.
For those who haven't read the plaque, we'll read the plaque that's on the front landing gear of this LEM. There's two hemispheres, one showing each of the two hemispheres of Earth. Underneath it says, "Dear men from the planet Earth, first set foot upon the moon, July 1969 AD. We came in peace for all mankind." It has the crew members' signatures and the signature of the President of the United States. Ready for the camera? Oh, I get it.
No, you're taking TV on him.
Touch the LEC there.
I'm afraid these lost materials are going to get dusty. The surface material powdery. I don't know how good your lens is, but if you can touches like gloves. Very much like a very finely powdered carbon, but pretty looking.
You pull out some of my cable for me, bud?
Houston, how close are you able to get things in focus?
This is Houston. We can see Buzz's right hand. It's somewhat out of focus. I'd say we were focusing down to probably about 8 inches to a foot behind the position of his hand when he was pulling out the cable.
Okay, how's the temperature looking there?
Temperature of the camera is showing cold.
I'm a little cool. I think I'll take. I'm on intermediate now, Houston, and I show 3.78. No flags, 74.
Houston, roger out.
And we'll probably need a little Distance, back location, television camera. And Neil, look at the minus Y strut. Your direction of travel there. Traveling from right to left.
Right.
So this one over here underneath the methane engine where the probe first hit. Minus my probe first hit.
I got plenty of cable.
You got plenty more. Okay, I think I got the end of it.
Something interesting in the bottom of this little crater here. Maybe.
Keep going. We got a lot more.
Okay.
Getting a little harder to pull out here.
If you stand on the ladder facing forward, the minus Y strut is the landing gear to your left.
Say I am, Buzz.
40, 50 feet. Why don't you turn around and let them get a view from there and
Okay.
see what the field of view looks like. You're backing into the cable.
Okay.
Turn around to your right, be better.
I don't want to go into the sun if I can avoid it.
That's right, yeah.
I just leave it.
All right, let it
Sit
settle
like
there.
that and walk around it.
Houston, how's that field of view going to be? Pick up the mesa far away?
Right. Neil, this is Houston. The field of view is okay. We'd like you to aim it a little bit more to the right, over.
Okay.
Okay, that's all the cable we have. All the way out. I'll start working on the shoulder.
A little bit too much to the right. Can you bring it back left about 4 or 5 degrees? Okay, that looks good, Neil.
Hey, that looks good, Neil.
Okay, now, think I ought to be farther away or closer?
Can't get too much further away.
Let's try it like that for a while. I'll get a couple panoramas with it here.
Roger, you look okay as far as distance goes, Neil, and we'll line you up again when you finish the panorama. You're going too fast on the panorama sweep. You're going to have to stop for...
I haven't stopped. I haven't set it down yet. That's the first picture in the panorama. Right there.
Roger.
It's taken just about northeast. Tell me if you got a picture, Houston.
Well, we've got a beautiful picture, Neil.
Okay, I'm going to move it.
Okay, there's another good one. Okay, we've got that one.
Okay, now this one's right down sun, straight west. And I want to know if you can see an angular rock in the foreground.
Roger, we have a large angular rock in the foreground, and it looks like a much smaller rock a couple of inches to the left of it, over.
Right, and then on beyond it about 10 feet is an even larger rock that's very rounded. rock is about, the closest one to you is about sticking out of the sand about 1 foot. It's about 1.5 feet long, and it's about 6 inches thick, but it's standing on edge.
Roger.
Okay, Neil, I've got the table out. The bag deployed.
We got this view, Neil.
Straight south.
Roger, and we see the shadow of the limb.
In the hills, Roger, the little hill just beyond the shadow of the limb is a pair of elongate craters. Probably the pair together is 40 feet long and 20 feet across, and they're probably 6 feet deep. We'll probably get some more work in there later.
Roger, and we see Buzz going about his work.
How's that for a final?
For a final orientation, we'd like it to come left about 5 degrees, over. Back to the right about half as much.
Okay.
Okay, that looks good there, Neil.
Yeah, it looks good there. Okay.
One hour, 7 minutes time expended.
Okay, you can make a mark, Houston.
Roger, slow in.
And incidentally, you can use the shadow that the staff makes to assist you in getting it perpendicular.
Buzz is erecting the solar wind experiment now.
Some of these small depressions big soft, and you tend to think, oh, maybe 2 or 3 inches. I can suggest exactly what the layer pictures showed when they pushed away a little bit. You can force transmitted through the upper surface of the soil, and about 5 or 6 inches away, it breaks loose and moves as if it were caked on the surface, when in fact it really isn't.
I notice in the soft spots where we have footprints nearly an inch deep that the soil is very cohesive, and it will retain a slope of probably 70 degrees on the side of the footprint.
All limb systems still looking good.
Okay? Yeah, I think that's nice. Dead end, come on. Going to get the camera. Head up to the rocker. Okay, you'll have to extend that one.
Columbia, Columbia, this is Houston, ALS, over.
Houston, ALS, over.
Neil Armstrong's been on the lunar surface now almost 45 minutes.
Thanks, man. I don't have a camera. Houston, Columbia on the high gain, over.
Columbia, this is Houston, reading you loud and clear, over.
Yeah, this is Houston reading. Yeah, radio loud and clear. How's it going?
Roger, the EVA is progressing beautifully. I believe they're setting up the flag now.
Great.
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right. I don't mind a bit. How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
Up now, and you can see the stars and stripes on the lunar surface. Beautiful, just beautiful.
See if you can pull that end off a little bit. Straighten that end up a little.
It won't go up. Okay.
Neil, this is Houston, radio check, over.
All right, you're Houston, loud and clear.
Roger out.
Loud and clear, Houston.
Roger, Buzz.
I'd like to evaluate the various paces that a person can traveling on the surface. I believe I'm out of your field of view. Is that right now, Houston?
That's affirmative, Buzz. You're in our field of view now.
You do have to be. All right, you do have to be rather careful to keep track of where your center of mass is. Sometimes it takes about 2 or 3 paces to make sure that you've got your feet underneath you. And about 2 or 3 or maybe 4 easy paces can bring you to a fairly smooth stop. Direction. Like a football player, you just have to put out to the side and cut a little bit. So-called kangaroo hop does work, but it seems your forward ability is not quite as good as it is in the conventional, more conventional one foot after another. As far as saying what a sustained pace might be, I think the one that I'm using now would get rather tiring after several hundred. But this may be a function of the suit as well as lack of gravity force here.
Tranquility Base, this is Houston. Could we get both of you on the camera for a minute, please?
Say again, Houston?
Roger, we'd like to get both of you in the field of view of the camera for a minute. Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you, over.
That would be an honor.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with Americans in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the Sea of Tranquility, it inspires us to redouble our efforts to bring peace and tranquility to Earth. For one priceless moment, in the whole history of man, all the people on this earth are truly one. One in their pride in what you have done, and one in our prayers that you will return safely to earth.
Thank you, Mr. President. It's a great honor and privilege for us to be here representing not only the United States, but men of peace of all nations, men with interest and a curiosity, and men with a vision for the future. Honor for us to be able to participate here today.
And thank you very much, and I look forward, all of us look forward to seeing you on the Hornet on Thursday.
Look forward to that very much, sir.
Columbia, Columbia, this is Houston, over.
Loud and clear, Houston.
Roger, I've got a P-22 auto optics pad for you.
Roger, go ahead.
Roger, P-22, landmark ID, LEM, T1 1102656, T2 1103206, 3 miles south. Time of closest approach 1103340. Shaft 353.855. Trunnion 46.495. Roll 0. Pitch 250. Yaw 0. Over.
Roger, thank you. Read back now required.
Roger, out.
Houston, it's very interesting to note that when I kick my foot this trail with no atmosphere here in this cavity, they seem to leave, and most of them have about the same angle of departure and velocity. Where I stand, the large portion of them will impact at a certain distance out. There are several certain percentage, of course, that will impact different regions out, but it's highly dependent upon initial trajectory upwards, determines where most of the majority of the particles come down, like the terrain.
Roger, Buzz, and break, Columbia, this is Houston. When you track out of high gain antenna limits, request Omni Delta, over.
Oh, man. I've noticed several times in going from the sunlight into the shadow that just as I go in, I catch an additional reflection off the LEM, along with the reflection off my face onto the visor, makes visibility very poor just at the transition sunlight into the shadow. I essentially have so much glare coming onto my visor, I'm under shadow until helmet actually gets shadow, and then it takes a short while for my eyes to adapt to lighting conditions. Inside the shadow area, visibility, as we've said before, is not too great, but both visors up, we can certainly get what sort of footprints we have and the minimal condition of the soil. Again, after being out in the sunlight a mile, it takes, watch it, Neil. Neil, you're on the cable.
Okay.
Yeah, lift up your right foot. Right foot. It's still, your toe is still hooked in it.
That one?
Yeah, it's still hooked in it. Wait a minute. Okay, you're clear now.
Thank you.
Let's move that over this way.
Neil Armstrong has the scoop for the bulk sample collection.
The boot color of my boots have completely disappeared now into this small. Still don't know exactly what color to describe this other than grayish cocoa color. Seems to be covering most of the wider part of the boot. Color that had very fine particles.
Buzz, this is Houston. You're cutting out on the end of your transmission. Can you speak a little more closely into your microphone, over?
Roger, I'll try that.
Beautiful.
Well, I had that one inside my mouth that time.
Sounded a little wet.
A little wet.
Neil's been on the surface an hour now. Buzz, not quite 20 minutes less than that.
In general, time spent in the shadow doesn't seem to have any thermal effects that we feel inside the suit. There is a difference, of course, in the coming radiation and the helmet, so I think there's a tendency to feel a little cooler in the shadow than we feel out in the sun.
Columbia, this is Houston, over.
Columbia, this is Houston, over.
One hour and a half expended on the PLSSs now.
Columbia, this is Houston, over. Columbia, this is Houston, over.
Houston, Columbia, Delta.
Roger, you should have VHF AOS with the LEM right about now. VHF LOS will be at 40 minutes, 15 seconds, over.
Thank you.
Heart rates on both crewmen averaging between 90 and 100. Flight surgeon reports they're right on the predicted number of the BTU units expended in energy of work. And he thinks they're in great shape.
If I look around the area, the contrast in general is comes about completely by virtue of the shadows. Almost deep. Looking down sun, zero phase, very light colored gray, light gray colored, like the halo around my own shadow, around the shadow of my helmet. Then as I look off cross sun, the contrast becomes strongest in that the surrounding color is still fairly light. As you look down into the sun, but a larger amount of shadowed areas looking toward us. The general color of the surrounding is darker than cross sun. Contrast is not as great. Surveying all the dusty area that we've picked up, considerably darker in texture. Now, I've picked up one. I imagine that this has been out by certain impacts that we've that's a distinct surveyor. The same is true if I survey cross sun along the area that we're walking. General, in addition to the fact that there are footprints there, general terrain where I've been up out of this surface trail is generally of a darker contrast, surrounding color.
You can see Neil Armstrong bringing scoop.
The ram I'll be taking is about 30 to 40 feet out the bus. But
Say again, which strut, please, Buzz?
So it seems the plus V strut.
Roger.
And, right in this area there are two craters. The one that's right in front of me now as I look off in about the 11 o'clock position from spacecraft, about 30 to 35 feet across, and several rocks and boulders 6, 8 inches across, different sizes.
Neil is filling the bulk sample bag attached to a scale. You can see him in the picture. Buzz is behind the limb at the minus Z strut. That's the landing gear directly opposite the ladder. Neil's been on the surface about an hour and 10 minutes now.
I'm now in the area of the minus Y strut. Taking some second photograph.
Buzz is making his way around the LAM, photographing it from various angles, looking at its condition on all sides. Neil's still occupied with the bulk sample. One hour, 40 minutes time expended on the PLSSs now.
How's the bulk sample coming, Neil?
Bulk sample is just being sealed.
And Columbia, this is Houston. While I'm talking to you, LOS will be at 111, 19er, 31. ALS 112, 05, 43. Over. Columbia, this is Houston. Did you copy LOS, AOS times? Over.
Copy. AOS.
Negative, Houston. You're broken. Disregard. I cut them off the flight plan.
Roger, out.
The DOS deflector that's mounted on quad 1 seems to be a good bit more wrinkled right now on quad 4.
You're breaking up again, Buzz.
Breaking up again, Buzz.
I say the jet deflector that's mounted on quad 4 seems to be, the surface of it seems to be more wrinkled than the one that's on quad 1. Generally, underneath part of the lem seems to have stood up quite well to the, we'll get some pictures in the half part of the lem that illuminate the thermal effects much better than we could get them up here in the front.
Roger, out.
I want to get some particular photographs of the bulk sample area, Neil.
Okay.
And Houston, Buzz here, I'm showing 3.78 SI. 3%, no flags. Adequate. Light warming, fingered.
Roger, and Neil has 66%, O2, no flags, minimum cooling, and the suit pressure is 382.
Houston, roger, out.
Neil has finished collecting and packing the bulk sample.
Buzz, this is Houston. Have you removed the close-up camera from the Mesa yet? Over.
Negative, thank you. Got it? Got it. Houston, how does our timeline appear to be going?
Roger, it looks like you're about a half hour slow on it. We're working on consumables, over.
All right.
Neil and Buzz, this is Houston. To clarify my last, your consumables are in good shape at this time. The 30-minute reference was with respect to the nominal timeline, over.
Roger, I understand that.
Neil's been on the surface now slightly over an hour and 20 minutes.
Don't note any abnormalities in the limb. Quads seem to be in good shape. The primary and secondary struts are in good shape. Antennas are all in place. There's no evidence of problem underneath the limb due to either the engine exhaust or drainage of any kind.
Roger, out.
It's very surprising, very surprising lack of penetration of all four of the foot pads. I'd say if we were to try and determine just how far below the surface they would have penetrated, you'd measure in 2 or 3 inches, wouldn't you say, Neil?
At the most, yeah. That fly strut there is probably even less than that.
All right, great job. I get a picture of the bus-wide strut taken from here, the descent stage, and I think we'll be able to see a little bit better what the ripple effects are. Seem to be quite minimal. picture taken the right rear of the spacecraft, looking at the skirt of the descent stage. So a slight darkening of the surface color, a rather minimal amount of radiating or etching away or erosion of the surface. And now on descent, both of us remarked that we could see a large amount of very fine dust particles moving out. It was reported beforehand that we would probably see an outgassing from the surface after actual engine shutdown, but I recall I was unable to verify that. Just too big an angle, Neil. Yep. I think you're right. Go back at the minus V strut now. Stereo pair we're taking to the bed will take very little force of impact that we actually had. And Neil, if you'll take the camera, I'll okay to work on the SEQ bay.
Okay. Columbia, Columbia, this is Houston.
I noticed that.
Columbia, this is Houston. Go ahead, bud.
Okay. Taking some close-up pictures of that front. I was saying that Houston stop and take a photograph of something and then want to start moving again sideways. Quite a tendency to start doing it with just gradual sideways hops because you start getting momentum.
Roger.
Can you see us underneath the slam over at the SEQ bay, Houston?
Yes, indeed, Buzz. We can see your feet sticking out underneath the structure of the LEM descent stage. Underneath the structure of the LEM descent stage.
Okay, I'm just on the other side of the...
Now we can see you through the structure of the minus Z secondary strut.
The SEQ bay
We don't necessarily need one high gain, but we're going to lose him
scientific
altogether.
experiments to be left on the surface of the moon. The laser reflector.
They're open, and it looks like they're going to stay up without any problem.
Columbia, Columbia, this is Houston. We're about to lose you on the Omnis. Request high gain antenna. React mode. Pitch 20. Yaw 135. Over.
It's 175, flight.
Gonna pick an area, Neil.
Make that yaw 175. Columbia, yaw 175 on the high gain.
Columbia's locked up on the high gain, Houston.
Roger out.
Sergeant, full flight. Go flight. How you doing? Good, real fine. They're still working below the predicted curve now. EMU flight. Go ahead, flight. How you doing? We're getting an update here in a minute. I'll get it to you in a second. All right. Flight econ.
Surgeon says everything looks fine.
Go ahead. Once again, our mixing valve has worked very nominal. Roger. You might tell Columbia that, Capcom. Stand. Okay. Yes. He can if he's watching it. He may not be watching it at the time.
An hour and a half
Flight
of lunar
Capcom.
surface
Capcom.
time.
And talking to Ecom, he says that if Columbia is watching it on board, he can see it. You think we ought to tell him about it anyway? Over? No, disregard. Roger.
Houston, the passive seismometer has been deployed manually.
Roger.
They've been on the portable life support systems for 2 hours now.
And the manual deployment of the LR cubed little spring that's at the end of the string pulled off of the pit fin. Now, however, I was able to reach up and get hold of the pit fin and pull it loose. So it'll be deployed manually also.
Roger.
And the panorama is complete in the limb, about the limb 7 and 730 position at about 60 feet.
That's Neil Armstrong to the left of the screen. By that.
Doors are closed and locked.
Roger.
Have you got us a good area picked out?
Yeah, I think right out on that rise out there is probably as good as any.
FBL, meet guidance, smoker down.
Right over here.
But probably stay on the high ground there and
Watch at the edge of that crater is
yeah,
rather
that's real
soft.
soft there, isn't it?
Got a couple of close-ups on these quite rounded, large boulders.
Buzz Aldrin coming into view on the right, carrying the two experiments.
About 40 feet out. I'd say out to the end of that next...
Well, it's going to be a little difficult to find a good level spot here.
Top of that next little ridge there, wouldn't that be a pretty good place?
Okay, how about I put the LR cube right about here?
All right. And,
I'm going to have to get on the other side of this rock here.
I would go right around that crater to the left there. Isn't that a level spot there?
I think this right here is just the level.
Okay.
And they will be out of the camera's field of view while setting up these experiments.
The boulders look like basalt, and they have probably 2% white minerals in them, white crystals. And the thing that I reported as vesicular before, I don't believe I believe that anymore. I think it's small craters. They look like little impact craters where BB shot has hit the surface.
EMU flight. Go ahead, flight. How you doing? Okay, it looks like we recovered a little bit. We've got about 15 minutes, and for the extension be on the 240. Consumable-wise, how you counting the 240? Where'd you start? The clock up. Are you on the clock up front? Roger. That's the one that was started when he Buzz hacked his watch. Depressurize the cabin, Roger. We just keep slipping the activities back and projecting our profiles. And the current rate right now is around 15 minutes beyond 240. Okay, and you're going with that clock up there? That's fine. FBO, meet guy and smoker that.
Hi, Houston, I have the seismic experiment flipped over now, and I'm aligning it with the sun. I'm having a little bit of difficulty getting the beef go in the center. Wants to move around and around on the outside. Find any spot, any hole.
You're cutting out again, Buzz.
Roger, I say I'm not having too much success in leveling the PSE experiment.
Flight experiments. The main thing is get the ball off the edge. Get what? Get the ball off the edge. It does not necessarily have to be centered if you can't center it. Get the ball off the edge.
Yeah, he said he was having trouble getting it off the outside at all.
I thought he said getting out center. I miscopied then.
So it seemed to be going around the outside.
The laser reflector
EMU
is
flight EMU. Is that 15 minutes on water? That's affirmed.
installed and the bubble level.
That was based on the last update we had. We're still looking to
appears to be good.
Roger.
Neil, this is Houston. Roger, out.
Hey, you want to take a look at this BB, see what you make out of it?
I found it pretty hard to get perfectly level too.
That baby likes the outside. It won't go on the
Experiments,
inside.
Flight experiments. I think I drowned him out. I think he just said it stays on the outside.
Cup is convex now instead of concave.
I think you're right.
I believe it is.
Houston, I don't think there's any hope of using this leveling device to come up with an accurate level. It looks to me as though the cup here that the BB is in is now convex instead of concave, over.
Let's have him not to fight it too long a flight. Let's press on. Forget it.
Roger 11, press on. If you think it looks level by eyeball, go ahead.
Okay.
Surgeon from flight.
The bubble they're
Flight, they
discussing
look okay to
is
you?
on a leveling
Here's
device
predicted.
on the
Okay.
passive seismometer.
Our rates are still down at a comfortable level.
One going, huh?
Okay, Capcom FAO flight surgeon and EMU on the loop. Okay, it looks like we can stand about another 15 minutes based on water. Surgeon says they're doing okay.
There you go.
Seems to me we ought to tell them that we're good for an extra 15 minutes and we'll give Buzz a mark at -10 when to start in, okay? Do you agree? That's fine. Flight EMU, go. The number looks a little better than that here.
Houston, the
15's fine.
facing the PSE, the right
Surgeon, you
hand
agree?
solar array deployed automatically. The left hand I had to manually
And FAO, how far are we away from that 10-minute mark based on that?
Hey, we 208 plus 15, 223.
and all parts of the solar array are
Okay, we'll take a little more off that because we'll have two wrong.
Buzz, this is Houston. I understand you did successfully deploy both solar arrays, over.
Roger, affirmative.
Capcom flight. Red flight for Neil, based on consumables, and
And there isn't any way of telling whether that's lined up.
we can give him another
Okay,
15
so maybe
minutes
I can
and
get
still
down
give
here.
a -10-minute mark for Buzz to start termination, if he concurs.
Okay, is Neil ahead or behind Buzz on consumables?
I think Neil's ahead. Is that right, EMU? Flight EMU? Neil's using less, right?
Still, that appears to be
That's
plenty.
confirmed. LMP is the one that's down. Okay, go ahead, Capcom.
Okay, for my information, would Buzz then be going in closer to nominal time?
I don't follow you. We're going to give the total thing 15 minutes, and we'll still give Buzz a 10-minute -10 mark to start in based on that.
All EVA 15 minutes.
Yes, if he agrees.
Neil, this is Houston, over.
Houston, over. Hey, go ahead, Houston.
All right, we've been looking at your consumables, and you're in good shape. Subject to your concurrence, we'd like to extend the duration of the EVA 15 minutes from nominal. We will still give Buzz a hack at 10 minutes prior for heading in. Your current elapsed time is 2 plus 12, over.
And that means Buzz would have to start back in at about
Okay, that sounds fine.
Roger out.
flight experiments. While they're out there with the camera, we'd have time to get a picture of the bubble. Is he still there? Roger, you're still in the vicinity. I haven't seen him come back from the side of the TV yet. You can try it if he hadn't left it. Who's got the camera, boys?
2:12 is the time expended on the PLSS.
This is Houston. If you're still in the vicinity of the PSE, could you get a photograph of the ball level? Over.
I'll do that, but
Right, we'll get a photograph of that. Houston, what time would you estimate we could allow for the documented sample? Over.
Stand by. FAO. Approximately 10 minutes. Pardon? Approximately 10. Approximately 10, Capcom. Capcom.
oh,
Approximately 10.
Say again, sir.
Approximately 10 minutes.
I believe the ball is right in the middle now.
Wonderful. Take a picture before it moves.
You only pass.
He asked what would we estimate for the document, and we're estimating about 10 minutes.
Neil, this is Houston. We're estimating about 10 minutes for the documented sampling. Over.
Ecom flight, did you get your message to Capcom? Yes, flight, did. Okay.
Say again.
You got a message for Columbia?
Roger.
On battery charge?
Flight network, we have good ESEP data.
Okay.
Columbia, this is Houston. Over.
Go ahead, Houston, Columbia.
Roger, I'd like you to terminate charging battery Bravo at 111 plus 15. Over.
How about right now?
Roger. Buzz, this is Houston. You've got about 10 minutes left now prior to commencing your EVA termination activities. Over.
Termination activities, over. Roger, I understand.
Flight experiments. Go ahead. Roger, we've uncaged. Working well. Say a lot of short period seismic activity. Short period Z.
You want to pass it up?
Yeah, you can tell them we're seeing some info on that.
Tranquility Base, this is Houston. The passive seismic experiment has been uncaged, and we're observing short period oscillations in it. Over.
Flight EVA, go.
Neil Armstrong
2:26
is
in
on
the
the
bottom
surface
line.
now, about an hour and 50
Okay,
minutes.
so we got to start him in now. He's got 9 minutes. Okay, we're supposed to give him 10 minutes prior to the bottom of the ladder, right? Yeah.
Hey, we gave him a 10-minute.
Great. Yeah, but he can utilize that 10 minutes as long as it's at the bottom of the ladder. Yeah, he understands that, right? Okay, yeah, sure. Econ flight.
Flight Econ.
Did you get your battery charge off?
Yes, the battery charge was terminated and everything looks good for LOS flight.
How about you, GNC? Everything looks good, flight. We're good. Roger. Telcom, how are you? We're looking good, flight.
In the foreground, Buzz Aldrin is collecting a core tube sample.
I hope you're watching how hard I have to hit this into the ground to the tune of about 5 inches, Houston.
Roger.
Experiments flight.
It almost
Two
looks
core
correct.
tubes and the solar winds, what you want? Experiments.
Got it. Sample.
Experiments, give me an answer. Two core tubes in the solar wind? Roger. Okay.
Wait a minute. Yeah, cut the cable again.
Neil and Buzz, this is Houston. We'd like you to...
You're right. Turn to your right.
Not clear?
Not quite.
Neil, this is Houston. We'd like you all to get 2 core tubes and the solar wind experiment. 2 core tubes and the solar wind, over.
Roger.
The core tubes provide material.
I'm getting the next flight. Experiments. Go. We have seen the core samples as he was taking those on the seismic data. If possible, sometime in the next couple minutes before he comes in, if he could get a little jump, which he was planning on doing at one time as he left the PSC, we'd like to have it. A jump. Roger. Let's let him get through with what he's trying to do.
Buzz, this is Houston. You have approximately 3 minutes until you must commence your EVA termination activities, over.
Roger, understand.
Columbia, this is Houston. Approximately 1 minute to LOS, over.
1 minute. Columbia, Roger.
And do you plan on commencing your sleep on the backside this pass? If so, we'll disable uplink to you while we're talking to the LEM, over.
Capcom flight. Good flight. After we get this core tubes and the solar wind, if we can get anything else into that box within the time.
Houston, were you able to record in a documentary way where the 2 core tube samples were taken?
Do we experiments?
Negative.
Tell them what I said, Capcom.
Yes, we want to...
I didn't get a stereo pair of those tubes, but they're right in the vicinity of the solar wind.
You said anything else I can get in the box?
That's right.
Neil, this is Houston. After you've got the core tubes and the solar wind, anything else that you can throw into the box would be acceptable.
Columbia.
I do. Cap was right.
I got the cap.
Got the cap?
They both got caps on around.
Okay.
And you want to pick up some stuff and I'll
Get these receptacles.
throw the solar wind in.
EMU flight. Go ahead, flight. How you doing? We're real fine, flight. You know, we had a little extra lifetime there. Okay, Sergeant Flight, how are you? Doing fine, flight. Roger.
Buzz Aldrin retrieving the solar wind experiment.
Buzz, this is Houston. It's about time for you to start your EVA closeout activities.
Capcom flight. Go ahead, flight. Who gets the film?
Roger.
Buzz or Neil? On the close-up camera? Roger, I'm looking
They've been on their life support system. On their life support systems, 2 hours and 25 minutes.
How about film magazine? And Neil gets that too. So he gets the stereo cassette and the film magazine? Roger. Well, like this EVA, the LMP is supposed to help him get that cassette and put it in his pocket for him so he doesn't have to fumble with it trying to get it in his pocket. Okay, where's the LMP? I think the LMP's at the Mesa. Remind him of the close-up camera, Meg. Affirm.
Yeah. Neil and Buzz, this is Houston. I'd like to remind you of the close-up camera magazine before you start up the ladder, Buzz.
Camera magazine before you start up
Okay. Got that over with you, Neil?
Now that close-up camera's underneath the Mesa, I'll have to pick it up with the tongue. And I'm picking up several pieces of really vesicular rock out here now.
You didn't get anything in those environmental samples, did you?
Not yet.
I don't think we'll have time.
No, they don't have time for that, Capcom. Press on with the close-up camera and close up? Yeah, let's get Neil, Buzz started closing up.
Roger, Neil and Buzz. Let's press on with getting the close-up camera magazine and closing out of the sample return container. You're running a little low on time.
Roger.
We want to keep a good margin in those portable life support systems.
Okay, can you quickly stick this in my pocket, Neil, and I'll head on up the ladder.
Capcom flight. Good flight. What Buzz just say? He asked
Oh,
me to put the close-up camera film in his pocket and he'd head up the ladder. My flight plan shows, right.
Around there, fella. Take it. Hold it. Okay, Joe. Okay, let the pocket go.
Popcorn.
Got it.
Okay. Adios, amigos.
Hey.
Anything more before I head on up?
Could we get the ladder? One jump, please. Up the ladder, Capcom.
Negative. Head on up the ladder, Buzz.
Head on up. Buzz.
That white dot right above the horizon on the right is a phosphorus spot from the TV converter in the Park station in Australia.
EMU flight. Go ahead.
Okay. You get the solar wind roll there?
Right, that's it right there. I think you can reach this hook that's hanging over here. You might entertain the idea of sending up the second one that way.
Okay.
Get the film off of that.
Oh well. Better now.
Okay, I'm heading on in.
Okay.
And I'll get the LEC already. About 5.
Telcom, control flight. Go flight. Watch your switches and circuit breakers now.
Hi, Raj.
Neil's been on the surface a few minutes longer than 2 hours. Buzz, approximately 20 minutes less than that.
Neil, this is Houston. Did the Hasselblad magazine go up on that sample return container also?
I've got the Hasselblad magazine hooked to the SRC now, yeah.
Roger.
Flight, we're right on it now, as EVA. Say again? We're right on the timeline with that plus 15. Ecom GNC flight. Flight Ecom? Okay, well, Mike's on the backside now. Let's get everything in order.
How you doing, Buzz?
Configuration for sleep on the CSM.
Roger, flight.
Ready to send it up the LEC?
Yeah, just about.
Okay, that's got it clear.
Transferring the sample containers into the LIM cabin now.
Uh-oh. Camera came off. I mean, the film pack came off.
Okay, just ease it down now. Don't pull so hard on it. Alright, let it go.
Flight surgeon. Go, surgeon. Okay, we feel like it's CDR.
Oh, you're getting that. I'm going to get the camera.
Heart rate here for a sufficient period of time. We ought to ask him to slow down and rest. You want an EMU check?
Okay,
Yes, sir.
this one's in no problem.
Let's get an EMU check on the commander.
Neil, this is Houston. Request an EMU check over.
EMU check over. Roger, got 3.8. And I got 54 on the O2 and no flags. And my flow is in.
Flight experiments. Go. Lake Observatory, dig, get a return on the laser. Roger.
You want to pass that one up, Flight?
Negative.
The Lick Observatory in California reports a
Campground flight.
return on the laser.
Good, Flight. No response necessary, but we're in good shape on consumables on CDR.
Roger, how about the buzz?
Same story.
Neil and Buzz, for your information, your consumables remain in good shape. Out.
in good shape. Roger. That's coming, Neil.
Okay, I've got one side hooked up for the second box, and I got the film pack on.
Okay, good.
Why, that film from on the LEC is kind of falling all over me while I'm doing this.
Well, that's good, huh?
It looks like down here.
I think my watch stopped, Neil.
Hit it.
Flight EVA. Go. We haven't heard anything about Buzz doing anything about that sequence camera up in the spacecraft. I don't know whether it's worth mentioning or not, but it might be. He needs to put a new mag on and get some pictures of the LEC operation. I don't know if he is or not.
Okay, if you can just kind of hold it, but I think I can do the pulling.
Okay. Stand by a minute. Let me move back.
Okay, easy. All right, easy on the hatch now. Okay, I'll get it the rest of the way.
Flight surgeon, you
I'll
should
give it to you to,
say again?
Oh, hey,
You
just a
should
second.
still continue to take it easy.
Have a little more.
This is the hardest part. I know it.
Two hours, 40 minutes on the PLSSs.
Buzz?
Okay, it's unhooked.
How about that package out of your sleeve? Is that?
No.
Okay, I'll get it when I get up there.
Got it now?
Yes, sir. Okay?
Okay.
Flight EVA, if they drop that mag, they ought to get it. Did they get that mag, Capcom?
Neil, this is Houston. Did you get the Hasselblad magazine?
Yes, I did.
Thank
And
you.
we got about, I'd say 20 pounds of carefully selected, if not documented, samples.
Houston, roger. Well done. Out.
In the second box.
Unofficial time off the surface at 1:11:37:32.
Now start arching your back. That's good. Plenty of room. Plenty of room. All right, arch your back a little, your head's up against. Out, off, roll right just a little bit. Okay, now. And in good shape.
Thank you.
Telcom flight.
I'm bumping now.
Now you're clear. You're rubbing up against me a little bit.
Okay.
Turn. All right, that's right. Turn to the left.
Telcom flight. No flight. What's your channel, please? Channel 32.
Now move your foot and I'll get the hatch.
Okay.
Okay, the hatch is closed and latched. And verified secure.
Okay.
Pressurizing. Yeah, that's what I'm looking for. Repress open flight. Cabin coming up. Roger.
pressure coming up
Real quick,
about
Cliff,
2.7,
MPAD would like us
8,
to have
9
us
now.
support one more sighting if it's all right with you. We
Up to
haven't
3
seen
now.
it 3 times. That's affirmative flight. That's why they'd like to try this one last one. What new data do we have? Oh, just MPAD science. Well, do we have a new set of coordinates? Oh, yes.
4
And what we'd like to
PSI.
do is uplink a statement to Columbia as soon as he pokes around the hill and reading this data. Just let him try one more time.
Hey, you're supposed to be getting some sleep in here somewhere.
No, not yet, Capcom. FAO flight.
Go flying.
Check your flight plan for Columbia from this point on, will you?
They show the cabin at 4.8
Our
now.
flight plan for at this point on, Columbia goes to sleep the same time the limb guys do.
That's what I thought.
That's right. Flight telecom cabin pressure is up.
Roger.
We're running about an hour later than this flight
Roger.
plan.
Okay, FIDO flight, get all your data together. We'll try it one more time. Roger, thank you, flight. FAO, will you get the information together?
Roger, flying.
GNC flight?
Flight GNC.
We okay on consumables or on propellant?
That's affirmative, flight.
Okay.
LEM's systems look good. Crewmen should now be transferring back to Tranquility Base's environmental control system, and later we'll switch to the vehicle's communication system. We estimate it'll be another 10 to 15 minutes before they're on the LEM communication system. And a replica of the American flag on the lunar surface is now being erected here in the control center. And a replica of the plaque on Tranquility Base has been hung on the wall.
Neil, this is Houston. Neil, this is Houston. Radio check, over. Buzz, buzz. This is Houston. Radio check, over. This is Houston. I copy a transmission calling Houston. All else was broken up, over. Neil, this is Houston. If you read, we suggest you unstow 1+ antenna so we can have communications, over.
A receive. B off.
Neil, this is Houston. We seem to be reading you now. How do you read us, over?
ICS push to dog.
Relay.
Houston, it's Tranquility. How do you read?
Tranquility Base, this is Houston. Loud and clear. How us?
Loud Loud and clear. We're in the process of switching over to LEMCOM here.
Roger. Tranquility Base, this is Houston. We'd like to verify your steerable antenna in track mode slew. We're going to do a communications handover here on Earth, over.
Roger, that's affirmative. We're in track mode slew.
Roger out. Columbia, Columbia, this is Houston, over.
Roger, Columbia on C Charlie, how do you read?
Roger, Columbia, this is Houston, reading you loud and clear on Omni Charlie. The crew of Tranquility Base is back inside their base, repressurized. They're in the process of doffing the plusses. Everything went beautifully, over.
Hallelujah.
And we'd like to get Pooh and accept from you. We have a state vector uplink, and after that, we'd like you to realign your platform to the new refs mat that we sent up a rev or two ago, over.
All right, understand. You want a option 1, please do option 1.
This is Apollo Control. Dr. Charles Berry reports the heart rates during this EVA period ranged from a low of 90 for both crewmen to a high of about 125 for Buzz Aldrin at peak periods, and a high of 160 for Neil Armstrong at peak periods. That top reading coming during the time he was transferring the rock boxes into the LEM. Dr. Berry says the data they got indicates Neil was working very hard at that time.
This is Houston. We're going to uplink you a new state vector, and then we'll send the ref mat up again because sending the state vector up will wipe out the one that you have on board, and then you can do a P-52 option 1, over. Columbia, this is Houston. Do you read? Over. Okay, Columbia, we've completed the uplink. The computer is yours. You can go to block. However, we'd like you to hold off on the P-52 option 1 align until after you pass landing site 2. And we're requesting that you perform another P-22 and attempt to find the LEM this pass. I've got some numbers for you when you're ready to copy. Over. Roger, Columbia, P-22. Landmark ID is Lunar Module. Make that Tranquility Base. T1 112 2508. T2 112 3017. 4 nautical miles south. Time of closest approach 112 3152. Shaft 357.051. Trunnion 047.432. Roll 0. Pitch 250. Yaw 0. Read back. Over. Columbia, this is Houston. Did you copy my P-22 update? Over. Columbia, this is Houston. Did you copy my P-22 pad? Columbia, this is Houston. Do you copy my pad? Over.
Negative, Bruce. Just give me the latitude, longitude over 2, altitude, and the grid squares. Never mind the other, you're broken up.
Stand by.
Well, that is if you have new information. Otherwise, I'll just use the old numbers.
No, wait a minute. We've got new information.
Okay.
This is Apollo Control at 112 hours 19 minutes. The inhabitants of Tranquility Base are still in the post-EVA cleanup period. Still have not fully configured the voice communications. However, we are getting telemetry, good telemetry from Tranquility Base, showing a cabin pressure of 5 pounds per square inch, temperature of 60 degrees. We expect to establish communications before too long. During this period, the crew is removing the portable life support systems, checking over their spacecraft systems, getting ready for jettisoning equipment from Tranquility Base. The cabin will be depressurized before too long, and equipment will be jettisoned onto the lunar surface.
Tranquility Base, this is Houston. Can you give us some idea of how you're progressing on the bliss doffing and preparation for depress?
Roger, Houston, Tranquility Base. We're in the process of using up what film we have, and I'm just getting ready to change the primary ECS canister. Over.
Roger, Tranquility. We'd like to hold off as long as possible on the lithium hydroxide canister. Make that one of the last things you do in getting ready for the depress if you can. Over.
Roger, we're planning on doing that. I'm just wondering how much longer we want to wait, though. We've probably got another half an hour's worth of picture taken, and I guess we could run through an heat cycle and then change the canister and then depress. Over.
Roger, that sounds fine to us.
Well, it'll be a little crowded in here for a while.
Oh, we don't mind a bit.
There went something. Looked like a portable life support system. There comes the other bliss. The experiments console reports the seismometer recorded both the impacts of those portable life support systems.